Okay, so we are on page 25, and today we're going to talk about swapping between factored form and standard form. That's actually what we're going to cover for the rest of this week and a little into next week, swapping between these two different forms for a polynomial. But today we're going to just look at changing from factored form to standard form. So we're going to start with factored form and change to standard form. So remember, standard form is where I've got all my terms multiplied out and placed in order, all like terms combined. The term with the greatest exponent on the variable comes first, and then it goes in decreasing order. So depending on what my exponents are, I may have a lot of terms. I may not have very many terms at all. We could only have one term. We saw some polynomials at the start of our unit where we only had one term, and that's just fine. But the thing with the biggest exponent should go first, and then in decreasing order until I get to the term that has no exponent at all that we call our constant term. Okay. I would like you now, for me really quickly on your calculator, to graph this function. You get something like this when you graph that function. So I want you to keep in mind that we're only seeing a small portion of this, but from this small portion, we can see the x-intercept here, and it asks us to state the x and y-intercept. So let's go ahead and find that x-intercept. Remember, we never need to guess with our calculators. I'm going to hit menu, analyze graph, and x-intercepts are called zeros on our calculator. So I'm going to select the 0 command, and then I want to, with this sort of dashed line, click on either side of my x-intercept. So I get an x-intercept at -3.5, -3.5. And then I want to know where my y-intercept is. There are a few different ways that we can do this. You guys saw this in Algebra 1. I'm going to go ahead and pull up the table. So I'm going to hit Control T. And remember, I can see my y-intercept if I scroll up to 0 in the table. The y-intercept is where I cross the y-axis, so that x value will be 0. So 0, 14. So let me put my calculator away and jot that down. I have an x-intercept. Again, at -3.5 is what I saw from my calculator. And a y-intercept at 14. Which of these can I actually see in standard form? Which of those values do I see in standard form? One of these numbers shows up in my standard form equation. That y-intercept, right? It's that constant term at the end. The y-intercept is our constant term from standard form. We're going to look at several different forms for functions. We've talked about 2 already in here. We're going to look at another one that you saw in Algebra 1 a little bit later on in this unit. But the reason that we care about all these different versions that we can use to write or represent functions is because they all tell me different pieces of information. So depending on what I want to know, Standard form may be more useful or factored form may be more useful, but they all give me some sort of information. So we talked about standard form. We also looked at factored form. Remember, for factored form, we would have our lead coefficient and then our factors here. Our lead coefficient only if it was a GCF. We could also see our lead coefficient sort of tucked into one of our factors. But we would have as many factors as we had for that polynomial. Sometimes they would have exponents on them, sometimes not. Here we have a function in factored form. I would like you to go ahead and graph this now on your calculator, and we'll find those x and y intercepts. Okay, so here's the graph I got from that second function. I can see some of my x-intercepts here. So it looks like we've got -2, no, -3, -2, and +2. We've already picked x-intercepts out of factored form, so that shouldn't be a surprise to us. What I can't see on this graph right now is the y-intercept. So again, I'm going to pull up that table. You could adjust your zoom to try and see it, but I can also get it pretty quickly from just pulling up my table and then arrowing up to when x is 0. So I've got x-intercept at -3, -2, and +2. I have a y-intercept at -12. So I'm going to flip my notes back up here and jot that down. And then we already know the answer to this question. We worked on it for a few days now, but which of these can I see from factored form? I get the x-intercepts from factored form. So there's a reason to care about both of these forms. Later this unit, we'll talk about vertex form for quadratics as well. And there's a reason that we'll care about vertex form. We did talk about vertex form in Algebra 1, but we'll talk about it again here in Algebra 2. There's a reason that I care about each of these things. These different function forms tell me important information. Because I get different pieces of information from these different forms of functions, I want to be able to swap between them so that I can get a complete picture of my function. So if we have a polynomial function in factored form, we can change it to standard form. We can change it to standard form by treating this like multiplication. That's essentially what I'm seeing here is multiplication, right? So I would distribute. So I can distribute or multiply and combine like terms. So that's what we're going to look at today. We're going to change these functions to standard form and then give their y-intercept. Now we've done multiplication already. We looked at that at the beginning of Unit 1. It was on the quiz that you took last week. So this is not a new idea. What I do want to reiterate, though, is when we're distributing and we've got more than 2 things that we're multiplying, remember, you only ever multiply 2 things at a time. So if I asked you to multiply 2 by 3 by 4, you could multiply 2 by 3 and get 6. and then you would take that 6 and multiply by 4. You wouldn't take 2 times 3 and 2 times 4 and then multiply 6 and 8, right? That would be too many 2s. So remember, we only multiply 2 things at a time. Once I've multiplied 2 things, I move on and I use what I got from there, just like when you multiply numbers. So as I'm looking at distributing here, I'm going to start by multiplying these first 2 terms. The order doesn't matter because for multiplication, the order in which I multiply things isn't important. So pick your favorite 2 terms if you'd like. I'm just going to pick the first 2. And we're going to distribute. So this would be x squared plus 2x minus 2x minus 4. And then I'm going to go ahead and combine these like terms here. So this would give me x squared, 2x minus 2x means I've got no more x terms, and then minus 4. So x squared minus 4. And now I'm going to take x squared minus 4 and multiply by that last term, x plus 3. And again, I'm going to distribute. Remember when you're distributing that we want to multiply this guy by everything over here and then multiply the next term by everything over here. So this would be x cubed plus 3x squared minus 4x minus 12. I don't have any like terms to combine here, and I'm in standard form already. The term with the biggest exponent is first. It goes in decreasing order down to my constant term. So this is my standard form function. What's my y-intercept? -12, perfect. And then we're going to do the same thing with this next function. Now here I have 1, 2, 3, 4 things to multiply. That's okay, I'm going to treat it the same way. So I'm going to start by multiplying the first 2 things. So -2x minus 6. Now I'm going to multiply this by the next thing in my list. And again, distribute. So this would be -2x squared plus 6x minus 6x plus 18. I'm going to combine like terms here. 6x minus 6x means my x's are gone. And I've got -2x squared plus 18. And then I'll multiply by my last term, x squared plus 5. So when I distribute, I would get -2x to the 4th minus 10x squared plus 18x squared plus 90. I have some like terms to combine this time. I've got multiple x squared terms. So my standard form function would be -2x to the 4th plus 8x squared plus 90. All like terms are combined. My exponents are in decreasing order down to my constant term. What's our y-intercept here? 90. Yep, it's that constant term at the end. What if I had something that looked like it didn't have a constant term? So what if I had this? What if this was my function? What would be my y-intercept for this? Yeah, 0. If I don't see it, that means that it's 0. Very good. So this is factored form to standard form. What you're going to look at in the next couple of days in your notes and what we'll work on in class is changing from standard form to get to factored form. And that's a process that we call factoring. So we're not going to work on factoring today, but that is what's coming. Question for me so far? Okay. So I guess I just lied to you a tiny bit. We are going to sort of introduce this idea of factoring today, but we're not going to get into in-depth factoring of polynomials. What we're going to take a look at is how we start factoring problem. So anytime we're looking to change something into factored form, the very first thing we want to do is look to see if there is a common factor among all of our terms. We call that a GCF, for greatest common factor. We want to look to see, is every term in this polynomial divisible by 2? If it is, let's divide every term by 2 to sort of simplify what we're going to work with. Does every term in this polynomial have an x? If it does, let's factor out that x to simplify what we're going to do in our next couple of steps. So that's what we're going to take a look at for today. This idea of pulling out a common factor, because that's going to be the first thing that we look at anytime that we factor a polynomial. So on the paper I just gave you, we're going to take a look at factoring out greatest common factors. So if I take a look at number 1, notice how both of these terms have an x. You see that? So if I want to factor this, which is what we'll work on for the rest of this week, the very first thing I want to do is take out anything that's already common. It will leave me with something simpler and hopefully easier to be able to factor with the strategies we're going to talk about later this week. So if I have an x with both of these, what I'm going to do is divide that x out, or factor that x out. So I'm going to pull the x out front, and then in parentheses, I'm going to write what's left over when I divide x out of each of these terms. So 5x squared, if I divide out x, so this in my head is what I'm doing. 5x squared divided by x. Well, that would leave me with 5x, right? This x down here reduces with one of the x's here. So that's what I'm going to write in parentheses. And then I've got negative 7x, and I want to divide out x. So those x's would be gone, and I would just have that minus 7. Now, the x that I divided out of each of these terms doesn't like disappear. Because I'm factoring, it's going to just hang out in front here. Anytime that I'm factoring using any of the strategies that we're going to cover, if I were to multiply this back, I should get the original problem. So if I distributed back here, I would get 5x squared minus 7x. See how that's the same as my original problem? Then I know I've done my factoring correctly. Okay, so what we're going to work on is this, but I want you to remember you can always check your work. Let's take a look at number 4. What do I have in common for all of those terms? They all have an x, right? Same as number 1. So I'm going to factor x out of all of those terms. That would leave me with x squared plus 2x minus 8. No, you don't have to do this in your work off to the side. If this helps you, absolutely. If you're pulling a number out as a GCF, maybe you need to do that, and that's fine. I'm doing that so that we're all clear on where those numbers in parentheses came from. Okay, so we have the idea, right? Let's take a look now at number 2. So I've got one term here and another term here. What do they have in common? What's a common factor to both of those terms? I could divide both of them by 6, and I could divide both of them by y. Right? And in fact, since they're both negative, I could divide them both by negative 6 if I wanted to. So I'm going to factor out negative 6y, and then in parentheses, I'm going to write what's left over from each of those terms. Negative 24 divided by negative 6 would be 4, and my y would be gone from this term as well. And then negative 6 divided by negative 6 would be a positive 1. I still have x cubed. Since I'm dividing out a y, I only have y instead of y squared, and I still have z cubed. What's common to both of my terms in number 3? I have a common factor of 3 there. So if I divide out that 3 or factor out that 3, I would be left with -1 plus 1x to the 5th. Let's take a look at number 5. So I've got a term here and I've got a term here. What factor do you see in both of those terms? Yeah, this time it's sort of a big clunky thing, right? That x plus 5. This is a common factor. I'm saying 6 times this thing, that makes it a factor. 7x times this thing, that makes it a factor. So my greatest common factor here is x plus 5. When I factor it out, I'd be left with 6 from this first term, and then minus 7x from the second term. Our GCF was clunkier here, but it's exactly the same idea as when we pulled out the x and when we pulled out the 3. How about for number 6? What would be our GCF there? 5x plus 4, right? This guy here is a factor for each of these terms. So I'm going to pull that out, 5x plus 4, and I'm going to write what's left. So I have 5x. Sometimes when we pull out the clunkier factors, I think it's easier to see what you have left if you just cover them up with your fingers. So I would have 5x minus 8. I'm going to put that here, 5x minus 8. And then I would have minus 3x plus 5. Minus 3x plus 5. Now, this stuff here, we can tidy up a little bit. This is really some polynomial subtraction in there. So this would be minus 3x minus 5. So I would have 2x minus 13 as my tidied up version. If I just clean up what's in the sort of big parentheses there. I want you now to try number 7 and number 8. Identify your GCF and factor it out for number 7 and number 8. What's your GCF for number 7? What factor is common to each term here in number 7? X minus 1, so we'll pull that out. And then what do I have left over when I factor out x minus 1? 4x squared plus 3x minus 1, very good. Maybe a little weird on this one, but not super difficult, right? Question. On 4, why did we divide what? Yeah, so x cubed divided by x is how we got the x squared, right? Okay. So we actually did divide here. So our whole term, if I look at this guy, was this, and I'm saying divide by x minus 1. So what we're saying is, hey, this is the same on the bottom and on the top, so I can cancel it the same way that we could cancel this x with one of the ones up here. Does that make sense? I'm still dividing it out, just the thing I'm dividing out is like clunkier. Does that make sense? Okay. Then how about number 8? What's our GCF for number 8? X. So I'm going to pull out x, and what's left? Plus x to the third. Very good. Let's hop up to number 9. What do I see in common on number 9? This x plus 4 piece is the same. The difference on this one, though, is that we've got some exponents here. So for some of our x problems, like number 4, we pulled out a single x because my term that has the fewest x's just had a single x. If this had been an x squared, we could have pulled out 2 x's because the least amount that any term had would have been 2 x's. Okay, so over here, we've got, for this second term, 2 of this x plus 4. That's the smallest exponent on this term, so I can pull out 2 of them. So I'm going to pull out x plus 4 squared, and that would leave me with, I'd still have 1 x plus 4 here, right? The same as we still had an x when we took 5x squared and divided out an x, right? So I've got 3 of them. I took out 2. I still got 1. And then we're taking out both of these guys. So we would just be left with minus 7. Does that make sense? Okay. Since I had exponents here, I can take out whatever term has the smallest amount of them. That's how many I can take out. And then on this guy, again, we can combine our like terms. This would be x plus 4 squared times x minus 3. What's my GCF for number 10? I can take out x. Yeah, they also have a 7 in common, and then I heard an x squared. Yeah, these both have exponents. I can take out whatever the smaller exponent is. So what would that leave me with if I factor out 7x squared? What am I left with for the first term? Negative. So if you need to, off to the side, like I did on number 1, you can do that division. So I've got no more x squared. Negative 14 divided by negative 7 would be negative 2. So negative 2. And then what's left here? X to the second. Very good. Hop down to number 14 for me. What's our GCF here? Do they all have an x? No. So it's not x. Yeah. And then 3 and 5 don't have common factors, right? There's nothing exciting to pull out of here. So I guess technically I could say I have a GCF of 1, but that would look like this if I factored it out. This seems really boring and silly, right? For a couple of the problems that we're going to look at, the next thing that we're going to see is something called factoring by grouping. In some steps of that process, we're going to be forced to take out a GCF. And if there isn't one, then this is what we're going to do. We're going to say, well, technically, it has a GCF of 1. Okay. Everything technically has a GCF of 1. So if there's nothing exciting, it would just be 1. Try 13. What's your GCF for 13? What common factor do you have for both of those terms? You got 3, 24, 9, both divisible by 3, and then I heard an x in there, right? X cubed, right? I can take however many the term with the smallest exponent has. And then these both also have y, and again, I can take however many the smallest exponent has. So this would be my GCF. What's left when I factor it out? Perfect. Let's take a look at 15. My GCF here would be 10x plus 9. How many of them can I take out? 4 of them, right? Again, that smallest exponent is 4, so I can take out 4 of them. Bless you. 10x plus 9 to the 4th. That would leave me with 4 plus 10x plus 9. And I could combine my like terms here. So I would have 10x plus 9 to the 4th times, this would be 10x plus 13. Questions for me on greatest common factors on GCF? You guys did, when you factored in Algebra 1, take out GCF. So this isn't a completely new idea, but some of the things that we're looking at pulling out as GCF are a little bit different than what you would have seen in Algebra 1. For homework tonight, you have a notes video assigned to you on Delta Math. It's over page 26, okay? So notes video for homework on page 26. It's assigned on Delta Math. So watch your video, take your notes. And when I see you tomorrow, we'll work on some of those practice problems based on the work that you saw on page 26.